Hi everyone, today we'll be doing question 254 on LeetCode called factor combinations. So we just want to find all factor combinations of a given number, knowing that 1 cannot be a factor. Cool, so let's talk about base case first. If we find that the value is 1, we just return an empty array. Cool, so this is obviously going to be a factor question. We're going to be using temp array to hold our changing array. Sorry, once again, this is a backtracking question because we want to find all possible combinations. So, I forgot to mention that. The result, product starts at 1, that would be multiplying an index that starts with 2 for our iteration because once again, the lowest factor must be greater than 1, so it has to be 2. So our backtrack function. It's going to take the temp array, the product, so it's the index. So if, let's say the product is greater than the number that we're using, we return, we skip it. If the product equals a number, we're going to push into our result. And we also want the iteration. So I equals index. I is less than, I'm going to do something a little bit different here. I'm going to discuss why we're going to leaving that blank for now. And then I plus plus. So in this case, we only want to push in values that are actual factors. So the only way to factor is if n% I equals 0, aka the number mod the value that we're iterating over is 0, aka it has a remainder. And if I doesn't equal the number itself, a number that we're iterating over cannot be the number itself, or else that means that it would have a factor of 1 as well, which cannot be true. Push it into the temp. We backtrack with temp, multiply the product by the current value. And since we're allowed to repeat values, so we can use 2, 2, and 2 here, we can write I here to repeat. And then at the end, pop it out. Cool. So let's discuss what we're going to do here. So usually we go all the way up to the value itself for the iteration, but this is not needed. In fact, we can just write something like this, because we know that for us to find another factor, it must be less than the number divided by the current product itself. So for example, let's say the product was 4 here, and our number was 8. The greatest number that we can go up to is 2 for that, so we go all the way up to 2 for this iteration. So let's invoke this and return the result. Let's see if this works. Works just fine. And works just fine. Cool. Runtime of this. This is a backtracking question, so it's going to have some kind of factorial runtime. And factorial, where n is the given number. Cool. So with that, I'll put a link to the question as well as my GitHub down below. And I'll see you guys next time.